Yeah, this is your tutorial for live session. Okay, here we'll discuss about generating sets, basis, linear independent set. Okay, so at first, please tell me what is the definition of linearly independent set.
Uh,
Please tell.
Sir, where the determinant of the matrices will be independent for zero, it will give
Sorry, I
for
still.
dependent set.
Yeah, I am still. We don't go to the matrix section. Okay, please try to give a give definition for the basic definition. You have one sets, okay, collection of some elements. So how can we check this is linearly independent or not? Suppose you have this collection, okay, a alpha. Alpha belongs to some index sets. How can we check this is a linearly independent or not? Yeah, please tell me what is the definition of linearly independent sets. Definitely of a vector space. Okay, this is belongs to some vector space V over a field F. Okay, yeah, please tell me what is the definition of linearly independent sets. You have this collection. You have this collection. When we will say that this collection is linearly independent, or at first take the finite sets. Okay, yeah, take the finite sets a1, a2 up to n. When we will say that this is a linearly independent? Yeah, please tell me.
Sir, when a1 alpha 1 plus a2 alpha 2 plus dot 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 an alpha n is not equal to 0.
Not equal to 0 or 0. Yeah, we will say that this collection is linearly independent. Okay, if alpha 1 a1 plus alpha 2 a2 up to alpha n equal to 0, when your alpha I belongs to the field, okay, where I equal to 1 to up to n, and all alpha are what?
Coefficients, they are no non-zero. Matlab, all
No,
should not
when
be
we are
zero
taking,
simultaneously.
when we are telling about linearly independent, then this alpha I must be 0. Okay, for all I. Yeah, we will say that this collection is linearly independent. Okay, if this has the expression after summing alpha 1 a1 plus alpha 2 a2 plus up to alpha n equal to 0, this must be imply or should be imply alpha I equal to 0. Okay, then we will say that this collection is linearly independent. Okay,
Yes, sir. Okay, sir.
yeah, and when we will say that linearly dependent, this is the linearly independent, and when we will say that this collection is linearly dependent, suppose you have this sets, when we will say this
Sir,
is,
when there exists some alpha I which is non-zero.
yeah, suppose this collection will said to be linearly dependent if, yeah, a1, sorry, alpha n equal to 0. Okay, when your alpha I belongs to the field set F and there are some non-zero alpha. Okay, there are some non-zero alpha I. Okay, for dependent, if we have this expression, okay, then all alpha I must be 0. For dependent, there must be exist one non-zero alpha I. Okay, these two are the difference of linearly independent and linearly this dependent in independent set all alpha I must be 0. In dependent set there must be exist at least one non-zero alpha. Okay, yeah, please tell me what is the generating set. Yeah, what is the generating set of generating set of a vector space of any set. We are telling about vector space, so we are taking generating set of a vector space. Okay, or we can take this is generating set of a set. You can also take this one, generating set of a set, or you can tell only that what is the generating set. Generating set. Okay, yeah, please tell me what is the generating set. You have one vector space over the field F. Okay, and you have we are talking about right now for finite. Okay, oh sorry, before going that we have to talk about for infinite what is the this there we are talking about the for finite case. Okay, you have the infinite collection. Okay, so you have this collection. Take yeah, from some index set I. When will say that this is a linearly independent set? Please tell me. Yeah, there we are talking about we are talking about the finite case. Okay, right now we are talking about infinite case. This is your collection of infinite element. Okay, so when we will say that this is the linearly independent set? Yeah, please tell me.
Sir, all alpha I will be 0.
No, please at first tell me what should be the expression. After that, tell all alpha are 0 or not. Here we are talking about finite case. Okay, here we are talking about finite case. Okay, right now we are talking about the infinite collection of elements. So when we will say that this collection is linearly independent? We will say this collection is linearly independent if at first you have to collect the finite number of elements from here. Okay, okay, and you have to take this sum equal to 0. Uh, take arbitrary for some for finite. Okay, alpha I 1 a alpha I 2 up to a alpha n. We are taking the finite number of element from this collection. Okay, this is the arbitrary. Okay, yeah, this is the arbitrary collection from this set. This is your infinite set. Here we are taking the arbitrary collection of finite number of sets. Right now we are we'll see that if your ci1 a alpha I1 plus ci2 a alpha I2 up to your cin a alpha n equal to 0. Okay, where your ci1 up to ci2 n all are belongs to from field sets, this will imply, if this will imply this one equal to ci2 equal to up to cin equal to 0, then we will say that this collection is linearly independent. You have to choose finite number, arbitrary finite number element from this collection A alpha. Okay, after that we have to try to satisfy what is the definition, what is the linear independent definition from finite sets. Okay, that's it. Understood or not? So this should be this must be true for all finite sub collection of this one. Okay, then we can say that this is a linearly independent set. It's understood, Ravi?
Yes, sir.
Okay, yeah. So now I am going to going for generating set. Okay, yeah. Please tell me what is the definition of generating set. Generating set. Yeah. Suppose you have this vector space. Okay. So please first we'll talk about finite generating set. Okay, finite generating set. Okay, first we'll talk about finite, then we'll talk about infinite. So you have one vector space over a field F, and you have this collection. Okay, a1 a2 up to n. When we'll say that this is a generating set of V. Okay, yeah, please tell me when we'll say that this finite set is a generating set of some sets, or, or this vector space V. Yeah, when we'll say that this finite collection is a generating subset of V. Definition is
Sir,
yeah, please tell.
sir, when through any operation we can generate the complete set using the element of this subset.
Yeah, please yeah, it's fine. Please try to explain explicit in mathematical form. We can generate every element of V. This is fine. This is fine. How we can generate? Or what is the relation between this finite set or every element of V? What is the relation between this finite set and every element of V? Yeah, please tell me. We'll say that this is a generating set of V if we'll choose any arbitrary element from V. Choose one X arbitrary element from V. Okay, then we can write X it as a linear combination of this one when I equal to 1 to n. Your CIR belongs to F. C must be C may be 0, non-zero, whatever. Okay, so when we'll say that this is a generating set of V if every element of X can be written as a linear combination of these sets. Okay, is it fine or not? Yeah, please tell me.
Can you explain me generating set again? I couldn't understand.
Okay, so you have one vector space, okay, V, okay, and this is your finite collection. Right now we are talking about finite set, then we will go for infinite. 1 minute. Yeah, okay, you have this collection a1 a2 up to n. This is your one finite collection from the vector space V. Okay. So my question, when we'll say that this is a generating set of V, or in other way we can say what is the relation between every element of V and these sets. Okay, this is my question. So at first we'll choose a arbitrary element from B. Choose arbitrary element from B. Okay, we are taking X is arbitrary element of B. Then we can write X is as a linear combination of these sets. Okay, C1A1 plus C2A2 up to Cn n, when all Ci belongs to your field sets. Okay, up to n. C may be 0, non-zero, whatever, but this Ci belongs to your field sets. Understood or not?
Yes, sir.
Yeah. So this is the relation between every element of V and these finite sets. So we'll say that this is a generating set of the vector space V. Okay. Yeah, for infinite set also same. Suppose you have this collection. Yeah, you have this collection. When we will say that this is a generating set of some vector space. Take this one also. When we will say that this is a generating set of V. Yeah, please tell me. Here it was your finite sets. Okay, this is a infinite sets. When we will say that this is a generating sets of some vector space V over field F. Okay, please tell me. Or in other way we can think what is the relationship between the every element of V and these sets. The same definition. Here X can be written as the linear combination of all A1, A2 up to N. Okay, but here X will be written as a finite linear combination of these sets. That's it. Take X arbitrary element from V, then we will say that this is a generating set of V if, okay, X can be written as your finite linear combination of your A alpha. Okay, so C1 also, or we can say that there exists one finite sets from this set such that X can be written as the linear combination of that finite set. Okay, so X equal to Ci1 A alpha I1 Ci2 A alpha I2 up to Cin A alpha In. Okay, where your all Ci1 up to Cin belongs to the field set F. Yeah, please tell me, it's fine or not? Here we are talking about the finite sets. Yeah, this was a finite sets, and we are talking about the when we will say that it's a generating set of V. Yeah, this is a collection of infinite sets. Okay. Oh my god. Yeah, yeah, this collection will say that this is a generating set of V if for every X for every element from V can be written as the finite linear combination of some element from alpha A alpha. It's fine or not? Please tell me.
सर इट इज सर आ रहा है समझ में, बस एक बार सर आप इसका कहीं एग्जांपल दे सकते हैं ऐसे सर में वेक्टर.
Definitely I'll give you example later. Please wait. Yeah, please tell me it is understood or not.
Yes sir, it will understand.
Okay, I will give you example later. I will give you some interesting example. Okay. Yeah,
Yes.
please tell me what is the definition of basis? Yeah. Please
Uh,
tell me.
Basis, the set of independent element through which we can generate the complete set.
Yeah. First tell
Through
about. Yeah. So
Sir, bases are the elements of which the linear combination we can generate the whole set.
this is only. Yeah, you are missing something. Please. Yeah, I am writing. Okay, you have one vector space V over a field F. Okay. Okay. First we are talking about finite, then we'll go for infinite sets. Okay. Yeah, you have this collection A1, A2 up to N. Yeah, please tell when we'll say that this collection is a basis of V. Yeah.
Sir, they has to be independent. These collections should be independent.
Okay.
Independent set.
And
Linearly independent, sir, and its linear span is equals to vector space.
yeah, so this collection must be satisfied linearly independent. This set must be linearly independent, and this must be generating set of V. Yeah, these two condition. Okay, then we will say this is a basis of V. Yes, similarly we can talk about the infinite collection. When we will say that this is a basis of V, same when if this is a linearly independent set, and second one is if it is a generating set of V. Yeah, for infinite case we already talk about what is the definition of linearly independent, and already we talk about what is the definition of generating set. Okay, it's not working. Okay, yeah, my god, it's too late. Yeah. Okay, yeah, go to your fourth assignment. Okay, yeah, this is one question, interesting question. Here we'll try to observe what is the relation between, okay, and we can say which cardinality is basically here we are talking about where we are trying to find the relationship between cardinality of linearly independent set and cardinality of your generating set and cardinality of your basis. What do you mean by cardinality of a set? Please tell me.
Sir, the number of element in that set.
Yeah.
That the cardinality.
Okay. So yeah, which cardinality is bigger? We are try to find out. Okay, is linearly independent set cardinality is bigger than generating set, or the cardinality of generating set is bigger than linearly independent set, and we're trying to compare with basis also. Okay, we'll see that linearly independent set, okay, cardinality of linearly independent set less equal to cardinality of basis less equal to your cardinality of generating sets. This is a relation between cardinality of these three sets. Okay.
Sir, dimension and cardinality are same. One and the same. Dimension and cardinality.
Dimension means cardinality of basis. Bas. Okay. Understood or not?
Can you repeat the relation, please?
Yeah, I'll prove also. Yeah. So, yeah, suppose you have one set A. Okay. Suppose you have one set A. We'll denote this is the cardinality of the set A. Okay. This is the notation of cardinality of the set A. Okay, so your cardinality of linearly independent set less equal to cardinality of basis less equal to your cardinality of generating sets. Okay. Suppose, what is the meaning of this less equal to? I have to explain properly also. Yeah, suppose you have one vector space V. Okay, so there may be a infinite number of linearly independent sets. Okay, so we'll consider the cardinality of all those elements. Sorry, or all those sets. Sorry, not element. All those sets. We are consider the cardinality of all linearly independent sets of V. Okay, and in vector space might be infinite number of bases. Okay, so we will consider the cardinality of bases also, and in vector space there are infinite number of generating sets. We will consider all the cardinality of all generating sets, then this relation will satisfy. Cardinality of linearly independent set, whatever linearly independent set have in your vector space V. Okay, this cardinality of linearly independent set means we are talking about, so you have many collection of an independent set. Okay, so we will take arbitrary one linearly independent set, and this is the cardinality of that arbitrary linearly independent set. As is same, this is also same. This is the relationship between cardinality of linearly independent set, basis, and cardinality of generating sets. Okay, understood or not? Please repeat if you don't understand.
So I will understand more than an example.
Yeah, I will give you example. Please wait. Yeah, this statement is okay or not? Please tell me right now.
Okay, sir. I understand that exact statement, but I cannot imagine that a statement without an
Okay, so I
example.
am going to the your assignment question 1. Then you will understand. Okay. Yeah,
Yes, sir.
go to assignment question 1. Yeah, your suppose yeah, so I am, let your V be a vector space over a field F. Okay, and take A1 up to N be a collection of linearly independent. This is the collection of linearly independent sets. Okay. Okay. Yeah, so
Sir.
yeah, right now consider this one, A1 up to A, and add one more element, A1 A2 up to N. Yeah, this is your linearly dependent, sorry, linearly dependent. Okay, if and only if I am writing the statement properly. Okay, oh, I am going go for if and only later. At first I am telling about this one. I'll go about if and only case later. Okay, first this is your given that this is a linearly independent sets. Okay, and consider this set, we are adding extra one element. Okay, this one extra element, this is your linearly dependent set. Okay, and but for every n Okay, but for every n of this vector are linearly independent. Okay, over the field F. Yeah, so this was your given that this is a linearly independent sets. We are adding extra one element with this sets, so it will be your linearly independent sets. So how, please tell me, what is the proof this of this statement? Here only we are adding extra one elements. Okay,
सर ये एक्स्ट्रा एलिमेंट जो है वो सारे जो लीनियरली इंडिपेंडेंट सेट के एलिमेंट्स का सम है।
सम लिया है, हाँ हाँ हाँ।
तो सर उसमें जो एक एलिमेंट किसी भी एक एलिमेंट जो है अगर वो लीनियरली इंडिपेंडेंट के सेट का है तो उन सबका जो वो निकलेंगे कोफिशिएंट्स होंगे उन सबको मतलब जीरो होना होगा अगर वो लीनियरली इंडिपेंडेंट है तो। तो सर का जो एक एलिमेंट मतलब जो एक एक्स्ट्रा एलिमेंट है वो क्या मतलब उन सबके सम में लिखा है तो उसका भी जीरो ही होना पड़ेगा उसका जो कोफिशिएंट बनेगा और फिर इस कोफिशिएंट के जीरो होने की वजह से टर्म जीरो हो जाएगा और फिर एक कोई टर्म ऐसा होगा जो बाकी के सम में लिखा जाएगा तो फिर वो हमारा लिनियरली डिपेंडेंट हो जाएगा वो सेट।
और वी कैन से दैट दिस एलिमेंट can be written as the linear combination of this one equal to 1 into a1 1 into a2 up to 1 into n, but this is also same. Okay, so this is your linearly dependent, but for every n of these vectors are linearly independent of F. Yeah, please tell me this one. Yeah, please tell me. But for every n of these vectors are linearly independent over F. Okay, so choose any element, any n element, okay, from this vector. Okay, uh, if we choose a1 up to n, they have already given that it was linearly independent. Okay, so we done. So next possibility is that we will miss one of the element from here and we will add this one. Okay, first possibility is that this element does not belongs to your this collection. We are taking the n number of, there are total n plus 1 elements is there, so we are choosing n number of element from this n plus 1. Okay, so first choice you have two choices like that. There are many choices also, but your important choice are two. One, in your in your n vector this sum maybe belongs or not. Okay, if this one is belongs to your collection, faster we are talking that this one is not belongs to your collection. Okay, first case we are consider first case that a1 up to an is not belongs to your collection. Okay, okay, then we done, because if this one is not belongs to our collections, so our collection is this one only, and by are already given that this is linearly independent, so we done. Case 2, case 2 is this expression, okay, a1 up to n is belongs to our collection. Okay, then at least one of a1 up to n, there at least one member must be missing. Suppose ai is missing, so our collection will be this one, a1 up to ai minus 1. ai is missing, the next one is ai plus 1 up to an, and sorry, yeah, please tell me how it is linearly independent. You have to prove that this collection is linearly independent, then we done. Yeah, please tell me. Case 1 is understood or not? Please, at first please tell me what case 1 is understood or not.
The case 1 is understood.
And case 2? What about
Case 2 not understood.
now you have to, yeah, so there was two possibility, that one is this sum may or may not belongs to your collection. Okay, there are total n plus 1 in number of element, so we have to choose n number element from that vectors. Okay, so two possibilities there, one is this sum is belongs to that your collections, or it may not be belongs to your collection. First case is not belongs to, then we done. Suppose it belongs to your collection, our collection, so we have to prove that it is linearly independent. So take the this expression, okay, up to ci minus 1 ai minus 1 plus ci plus 1 ai plus 1, okay, up to cn plus this is take your cn plus 1 a1 up to an equal to 0. So you have to prove that all coefficient must be 0. Okay, so what we'll do?
Yes.
Yeah, take try to rearrange this line. Okay, so we'll get c1 n plus 1 a1. Yeah, there was ai1 element was missing, but here we'll get that ai1. Okay, this is the interesting. Okay, ci minus 1 plus cn plus 1 ai minus 1, but here we'll get that ai again because of this expression. Okay, okay, this is fine. Up to your cn plus 1, or we can write in next line, it will be better, I think. Yeah, equal to 0. So here we have the all collection a1 a2 ai minus 1 ai plus 1 up to n, and already given that these collection are linearly independent, so your all coefficient must be 0. From here we will get that, first we will get that n plus 1 is 0. Okay, then we will consider the all coefficients. From here c1 plus cn plus 1 equal to 0, we will get c1 is 0 up to, we will get the all coefficient at 0. Please tell me it's understood or not. Yeah, please tell me it's fine or not. Rishu?
Sir, why coefficients are 0, sir? Is it given or what?
No, it was already given na that your this collection is linearly independent. A1 up to n is linearly independent. So already one linearly independent set was there. We are adding extra one element. What is the extra one element? This all the sum of that one. After that,
Okay, sir. Got, sir.
yeah. After that, we are try to check this collection is linearly independent or not. Okay. It's fine.
So please repeat last step.
Okay. So we have to prove that this collection is linearly independent. Okay. We have to prove this one. It's fine.
Yes, sir.
Yeah. So take this expression C1 A1. There was AI1 element was missing there here. Okay. So AI is not there. So C1 A1 up to plus CI minus 1 AI minus 1. This expression up to Cn an, and last one is this one, taking coefficient Cn plus 1, this expression equal to 0. Here AI was missing, but from here we will get that AI. This is interesting here. So we will get the linear combination of A1 A2 up to n. Okay, and this is your coefficient for A1, this is your coefficient for AI minus 1, this is your coefficient for AI, and this is your coefficient for AI plus 1. Okay, and this is your coefficient for your AN. And it was already given that this collection is your linearly independent sets. A1 up to n is linearly independent sets. So all coefficient must be 0. Okay, first we are look about AI. Okay, coefficient of AI is n plus 1. So since this all are linearly independent set, all coefficient must be 0. So from here we will get Cn plus 1 is 0. It is fine or not? Please tell.
सर Cn plus 1 कैसे हुआ, ये समझ नहीं आ रहा.
So please try to 1 minute. In these expressions, please tell me which elements are there from these sets. From these sets, which elements are appear in this expression? Yeah, please tell me at first.
Sir, A1, AI minus 1, AI plus 1, AN.
Yeah, AI minus 1, AI plus 1 up to your n. All coefficients. Here AI, A1, A2 up to AI minus 1, AI plus 1, n. All coefficients are here. Okay. In this expression, all coefficients A1 up to n are there. Okay, and we are getting the sum is 0. So and initially it was given that this is your linearly independent set, then all coefficient must be 0. Is it fine or not?
Yes, sir. Now I understand.
Okay, so it was your one linearly independent set was there. We add another one element, but it turns into linearly dependent sets. Okay, is it fine?
Yes, sir.
Okay.
Proceed, sir.
Yeah, from here we can say that cardinality of linearly independent set is less equal to. Okay, I will tell you later. Okay, so this is your one things. My God, I don't have time, but there is. Yeah, try to check question number B. Yeah, your question number B is like that. You have A1 up to AN. Okay, and A is another element, are linearly independent. Okay, over the field if and only if your a1 up to an are linearly independent, okay, over f, and a does not belongs to if a1 up to if an. Yeah, please tell me. a1 up to n and a total are n plus 1 element are there, are linearly independent over f. If and only if your a1 up to n are linearly independent over f and a does not belongs to this collection. If a1 means will multiply all element of f by a1, okay, and this is also similar, then we'll add this one. Yeah, so a does not belongs to this set. This is your if and only if conditions, okay. So this expression will be linearly independent over the field f if and only if your the first or n a1 up to n are linearly independent over f and a does not belongs to your this expression. Yeah, please tell me what is the proof. First assume that a1 up to n and a are linearly independent. First assume a1 up to an a are linearly independent over f. You have to prove that a1 up to an are linearly independent over f and a does not belongs to this one, okay. So first we have proved. So yeah, I am telling one thing. Suppose your some collection is linearly independent, some collections, okay. Suppose your here I am taking, yeah, it was our linearly independent sets, okay. If we take the sub collection from here, suppose a1 a2, this sub collection, this also must be linearly independent. Understood or not? Please try to understand my statement, then I'll go for proof, okay. Suppose you have these collections a1 up to n, okay. This is your linearly
Yes,
independent.
sir.
Yeah.
And any subset of a linearly independent
Independent set?
subset is linearly
Yeah.
independent.
Yeah, it's fine. Risu, is it fine for you?
Yes, sir.
Okay. Yeah, then it's fine. Yeah. So this is your linearly independent set. It is given. Okay. So this is your subsets of these sets. So this must be linearly independent. Okay. So now we have to prove only that A does not belongs to these sets. Okay. So what is our next term? Next term is we have to prove A is does not belongs to these sets. Okay. Please tell me it is.
Sir, but if and only if condition is there.
No, I am going to, we are assume this one and we are proving to next statement. Then we will go to forward. Okay, right now we are going to forward direction. Next we have to go to backward direction. Okay. Right now we are assuming this one, we will prove these two statement. Okay. So after that, after we assume these two statement, we will prove this one. Okay.
Sir, yes, sir, correct, sir.
So first we are assuming this one, these are linearly independent sets. So automatically this is imply your this one is also are linearly independent over f. Okay. So next term is we have to prove that A does not belongs to. We have to prove what we have to prove. We have to prove that A does not belongs to these sets. We have to prove. Okay, so assume suppose we are going to for contradiction. Okay, suppose or contrapositive. Okay, this is contrapositive means we have to prove this one. Okay, we have to prove that A does not belongs to these sets. We go for contrapositive. So if we assume that A belongs to these sets, so we will get some contradiction. Okay, so assume that we are assuming, let or suppose your A is belongs to these sets. Suppose, so we can write this one like that, C1 A1 up to Cn in all Ci belongs to your field F. Okay, okay, so what we can write, since your A is non-zero, okay, all coefficient can't be 0, at least there are at least one member who is non-zero. If all our member are 0, then A must be 0. Okay, so it is not possible. Since your A is non-zero, there must exist at least one element which is not non-zero. Is it fine? For some non-zero Ci. Okay, is it fine or not? Please tell.
Yes, sir.
Yeah, so what we are getting? We are getting C1 A1 up to Cn An minus A equal to 0. Okay, or it is not given that A is non-zero. A may be 0. If 0, then all coefficient will be 0. Okay, so don't assume this statement. If A is non-zero, then we will get at least one non-zero Ci. Okay, if A is 0, then we will get all our C1 are 0. Okay, so from here we can write this one. Is fine? Is it fine or not?
Yes, sir. Correct.
Yeah. So please look at the coefficient of A. Coefficient of A is -1. So at least we are getting one non-zero coefficients. Is it fine or not? All Ci must be maybe 0 or non-zero, we don't know, but coefficient of A is -1. Is it fine?
Yes, sir. Correct, sir.
Correct. So your collection A1 up to A are dependent sets. If we assume that A is belongs to this set, we are getting your this collection A1 up to A are linearly dependent over the field F, which is a contradiction. Okay, so A does not belongs to your this collection. Please tell me, it is fine or not? Is it fine? Please tell me. Please tell me it is fine or not.
Sir, A can be outside bit of A1 to An.
Yeah, A must be outside of outside of this sum. Okay, so we have to prove this one is outside of this one. So we are assuming, we are trying to prove is by contrapositive way. Means we are assuming that suppose if A is belongs to this set, then what will be happen? If A belongs to this sets, we are getting this collection are linearly dependent, which is a contradiction. So A must be outside of these sets. Is it fine?
Sir, why contradiction, sir?
Oh, it was given na
माइनस
that
वन है जो
this is your linearly independent set. It was given
Okay, okay, sir.
that
Got
we are
it, got
getting
it.
dependent. Yeah, Risu, you are telling something. Please tell.
sir इसका coefficient -1 that is non-zero, that is why it is LD.
Yeah.
Now I understand, sir.
Okay. So time is over. Okay. So you try to the opposite direction, and Risu was telling about give some example. Okay. So right now I'm stopping this one. Then I will give you example. Okay. 1 minute. Wait.